Given this equation, find an expression for dy dx in terms of x and y. Given that x equals this and y equals this, find an expression for dy dx in terms of t. Find an expression for d2y dx squared in terms of t, and find the value of d2y by dx squared when x equals 3. Okay, so here's the question in summary form then. Let's have a look at it. So it's an implicit function, so let's go along and differentiate it. So part A, here we're differentiating with respect to x. So this is the power rule, 3x to the 1 less, which is 2, plus, this is a product, so it's u, dv dx, so that's dy dx, plus v, which is y, times du dx, differentiate this, the 4 comes down to b with the 5 to make 20, x to the 1 less, which is cubed, so there's the product, minus, this is now a function of a function, so something cubed, the 3 comes down to b with the minus 2 to make 6, y to the 1 less, which is 2, multiplied by the something differentiated, which is dy dx. The constant goes to 0, equals, and 0 differentiates to 0. So that tells us then dy dx is here, and then we've got a 5x to the 4 here for this term, minus a 6y squared, so put that in a bracket, is equal to, and then move the other two terms over the other side. So this would be minus 3x squared, and then minus the 20 x cubed y. So that tells us then dy dx. Now I'm going to move this from times to divide, but I'm going to run a minus through top and bottom at the same time because this will then look easier on the eye. And I'm going to write the second term first, 20x cubed y plus 3x squared. So I've run the minus through those two. And then I move this down and run the minus through this, so it'll be 6y squared minus 5x to the 4. So there's dy dx then. So that's part A. Given that x is equal to t cubed, y is equal to this, find dy dx in terms of t. So here we need dx dt and dy dt, don't we? So dx dt, differentiate with respect to t, 3t to the 1 less, and the constant goes to nothing. Dy dt, differentiate 4t cubed, differentiating with respect to t, using the power rule. 5 comes down to be with the 7 to make 35, t to the 1 less than 5, which is 4, so that's dx dt and dy dt. So dy dx then is equal to dy dt divided by dx dt. 4t cubed plus 35t to the 4 divided by dx dt, 3t squared. There's a t squared common on the top and the bottom, so we can divide by t squared on the top all the way through. T squared, so divided by t squared here to get t1, and t squared here, we'll reduce that to t, just t squared. Divide by t squared, we'll have a 3 underneath, won't we? Okay, that's dy dx then, which we can write as 4/3 t, split the fraction up, plus 35 over 3 t squared. Okay, so that's part one. So now d2y by dx squared. So d2y by dx squared is equal to d by dt of dy dx multiplied by dt dx, isn't it? That's what we've got. We're differentiating dy dx with respect to x using this chain rule here. D by dt of dy dx then is this. Differentiate this with respect to t. 4/3, the t goes to 1, plus the power rule, 2 comes down, we get 7t over 3 lots of t. So that's d by dt of d by dx multiplied by 1 over dx dt. dt dx is 1 over this, which is 1 over 3t squared. So that's equal to then, run this through, 4 over 9 t squared plus 7t over 9t. So that's part 2. And find the value of 2y by dx squared when x equals 3. So part 3. When x equals 3, we need to get the value of t. So let's go back up. Put 3 in, when x is 3 in here. 3 equals t cubed minus 5. And that tells us that t cubed will equal, move the 5 over to be with the 3, to make 8. Cube root both sides, and that will give t as 2. So d2y by dx squared then will equal, put the 2 value in here. 2 squared is 4, and we'll cancel with the 4 on top, so it's just 1 over 9. 70 over 9 2's, well the 2 will cancel with the 70 and just give 35 over 9. So it's 36 over 9, which equals 4. So that's the value for part 3.